Hey there. All right, so I just wanted to do a demonstration for you so that you can visually see what we're talking about in class when we talk about finding the slope of the tangent line being a limit as x approaches a specific value of the slope formula. Okay, so we've talked about this green line here through my curve in 2 points. That's called a secant line. All right, I have this parabolic curve here in red. I have a secant line currently through the point 3, 0.25, and 6, 4. My purple line is my tangent line, and notice that my tangent line is only touching the curve at 1 point. And my job is to figure out what the slope of this purple line is. Now, graphically speaking, I could just find 2 points on this purple line, the 3.25, and some other point on this tangent line, and find the slope between those 2 points to estimate what the slope would be. But often we do not have graphs in order to do that, and this software graphs the tangent line perfectly, whereas by hand I would not graph the tangent line perfectly. So I need to have another method, an algebraic method. So the idea would be, hey, if I found the slope of this secant line, could I use that to estimate the slope of the tangent line? Well, the slope between the x values of 3 and 6 would not give me a very good estimate for the slope of this tangent line. But what happens if I choose an x value closer to 3, right? So if I choose an x value of 5, and I found the slope of the secant line between x equals 3 and x equals 5. Well, it's still not a good estimate of the slope of my tangent line, but as I move closer to an x value of 3, notice that my secant line is turning more and more into my tangent line. In fact, if I pick an x value of 3.46 and I find the slope between x equals 3 and x equals 3.46, the slope of that secant line is going to be closer to the slope of my tangent line than when I started way up here at x equals 6. Okay? So as I pick x values that are moving closer and closer to the x equals 3, my secant line looks more and more like my tangent line. In fact, here's 3 to 3.1. Notice that the secant line is very close to the tangent line, and I'm getting a really good estimate of what the slope of my tangent line could be. And the more I move this, the closer I move this, when I pick x values even closer to 3, notice at 3.01, the slope of the secant line and tangent line are going to be pretty much the same. In fact, on my graph here, it looks like the secant and tangent line are overlapping each other. So the idea is to pick x values that move closer and closer to the given point of tangency and use those 2 points on the secant line as the second x value moves closer and closer to the given x. Use those 2 points and the slope formula to estimate the slope at the point of tangency. Okay? And I could do that on either side. So let's see if I can separate this out a little bit. There we go. So I started on the left side of x equals 3, right? Okay, so here's at 0 basically. And this would be a terrible estimate. The slope of the secant line would be a terrible estimate for the slope of my tangent line. Right now, the slope of the secant line is negative, okay? But as I pick x values that move closer and closer to the x value of 3, I now have a positive slope at least, okay? But as I pick x values like 2.5, that secant line is looking more and more like the tangent line. So if I find the slope of the secant line between 2.5 and 3, I'm getting a better estimate for the slope of the tangent line at x equals 3. And as I continue to move closer and closer to x equals 3, again, you can see my secant line is becoming more like my tangent line. As I pick x values that get closer and closer to the given x and calculate the slope between the points with those x values, the slope of my secant line, okay, I'm going to get the slope of the tangent line. That's where the limit comes in. The limit as x approaches a. A is the point of tangency, the x value for that point of tangency. This would be the limit as x approaches 3 of my slope formula, change in y over change in x. And as those x values get closer, that slope is going to be more and more indicative of the slope of the tangent line.